Good morning, all. Hope all of you are fine. In this academic year, our class starts with a new manner. You, the students, are at home, and we, the teachers, are at the screen of mobiles and TVs. Hope we will meet in our classroom recently. Let us start our subject. In this year, in chemistry, we have 7 units, and the first unit is periodic table and electronic configuration. Before entering to the chapter, we want to recollect some basic ideas. We know that atoms. What are atoms? Anyone? What are atoms? Good. Atoms are extremely small particles in which all the substances are made. So, atom is the smallest particle. Okay. We know that atom consists of subatomic particles like electrons, protons and neutrons. Protons and neutrons are present at the center of atom. Atom have a very small center. What we call it as? Yes, nucleus. Good. Atom have a small center which is called nucleus. Around the nucleus, we can see circular paths. These circular paths are called orbits or shells. Okay, listen to the board. Related to atom, we want to recollect some terms. The first term is atomic number. Atomic number, which is represented by the letter Z. What is atomic number? Anyone? Yes, good. Atomic number is the number of protons present in an atom. Once more, atomic number is the number of protons present in an atom. It is represented as Z. The next term is mass number. Mass number, represented by the letter A. What is mass number? Good. Mass number is the total number of protons and neutrons present in an atom. Mass number is the total number of protons and neutrons present in an atom. So, two terms. First term is atomic number and the second term is mass number. Atomic number is the number of protons present in an atom. It also equal to number of electrons present in an atom, because an atom having equal number of protons and electrons. So, atomic number is also considered as number of electrons. Okay. The next one is mass number. Mass number is the total number of protons and neutrons present in an atom. Okay. Then atom have some shapes. Atom have some models. John Dalton introduced the first model. After that, Niels Bohr introduced the model. According to Niels Bohr, an atom have a central part called nucleus. Nucleus having two subatomic particles, protons and neutrons. Protons having positive charge and neutron is chargeless. Around this nucleus we can see circular paths like this. These circular paths are called shells. These circular paths are called shells. This is the first shell, this is the second shell, this is a third shell, and this is a fourth shell like that. The first shell is named as K, and the second shell is named as L, then M, then N like that. In these shells we can see electrons. First shell having 2 electrons, second shell having 8 electrons, third shell having 18 electrons, and the fourth shell having 32 electrons. We have an equation to find out the number of electrons accommodated in each shells. Anyone can say what is that equation? Good. 2n square. What is that equation? 2n square. By using this equation we can find out the number of electrons present in each shell. How is it possible? Suppose we want to find out the number of electrons in the first shell K. By using this equation, how can we calculate? Listen, K is the first shell. It can accommodate maximum 2 electrons. By using this equation we can find out it. How is it? Look at them. K is the first shell. So for n put the number 1. So 2 into 1 square. 1 square means 1 into 1, that is 1. 1 into 2, that is equal to 2. Okay. Then in the second shell is the L shell. How many electrons are accommodated in L shell? We can find out by putting 2 into L shell is the second shell, so put 2 in the place of n. 2 into 2 square. 2 square means 4, 4 into 2, 8, like that. In the same manner, third shell, which is the third shell, M shell. How can we find out the number of electrons accommodated in the M shell? All of you take a notebook, write this equation and find the number of electrons accommodated in K, L, M, N by using this equation. Ready? Speed up. Finish? Good. How many electrons are there in M shell? 18 electrons. Good. How is it possible? 2 into 3 square. 3 square means 9. 9 into 2, 18. Okay. Then what about in the fourth shell? 2 into 4 square. 4 square 16. 16 into 2, 32. Okay. So this is the Bohr model of atom. According to this model, as we move from the nucleus, the attraction between electrons and the nucleus decreases. As we move from nucleus to the last shell, we can see that the attraction between electrons, negatively charged electrons, and the positively charged nucleus decreases. In the same manner, as we move from the nucleus, the energy of electrons also increases. The electrons present in each shell have a definite energy. As we move from the nucleus, the attraction between electrons and nucleus decreases, whereas that of energy increases. Okay. In shells, we can see electrons. First shell having 2, second having 8, third having 18, and fourth having 32. In modern periodic table, the elements are arranged in the increasing order of their atomic numbers. In the left side, we can see hydrogen with atomic number 1, and at the right side, we can see helium with atomic number 2. So, in modern periodic table, we can see elements are arranged in the increasing order of atomic number. We have already studied that. What is atomic number? Atomic number is the number of protons present in an atom. Again, we look at the picture. First shell having 2 electrons. That means K shell having 2 electrons. In the second shell having 8 electrons. L shell having 8 electrons. Third shell, M shell having 18 electrons, and in the last shell, N shell having 32 electrons. This is known as shell electronic configuration. K having 2, L having 8, M having 18, N having 32. This is known as shell electronic configuration. That means distribution of electrons in various shells in the increasing order of their energy is known as shell electronic configuration. So, this is the shell electronic configuration. Can you write shell electronic configuration of some elements? Okay, listen. This is, what is the symbol of this? Na. Anyone? Good. Sodium. Na is sodium. This is the atomic number of sodium. So, the atomic number of sodium is 11. How can we write the shell electronic configuration of sodium? Anyone? Okay, good. K shell having how many electrons? 2. Good. Then L shell having 8 electrons. We have 11 electrons. So, K shell having 2, L shell having 8. 2 plus 8, 10. 1 electrons remains. So, M shell having 1 electron. So, what is the shell electronic configuration of sodium? 2, 8, 1. This is the shell electronic configuration of sodium. Good. One more example. All of you listen. What is P? P represents, anyone? Phosphorus. Good. What is its atomic number? 15. Then how to write the electronic configuration of phosphorus? Okay, good. 2, K shell having 2 electrons, L shell having 8 electrons, then M shell having 5 electrons. 2, 8, 5. Okay, good. All of you take your notebook. Write a question. Write the, speed up, electronic configuration of following elements. And the elements are, listen here, magnesium with atomic number 12, chlorine with atomic number 17, argon with atomic number 18. Write the subshell electronic configuration, shell electronic configuration of these atoms: magnesium, chlorine, argon. Okay, speed up. Finish? Okay, listen. What is the shell electronic configuration of magnesium? Yes, 2, 8, 2, total of 12. Okay. Then what about chlorine? 2, 8, 7, total of 17. Okay, good. What about argon? 2, 8, 8, total of 18. Okay, very good. Then one more atom. Listen. Next atom is potassium with atomic number 19. How to write the shell configuration of potassium? Okay, listen. First shell having 2 electron, because K shell can accommodate maximum 2 electrons. Then second shell having 8 electrons. 2 plus 8, 10. How many electrons remains? 9 electrons remains. Then third shell having 9 electrons. 9 electrons. No. Third shell having 8 electrons. Why it's so? Third shell having 8 electrons. Which is the third shell? M shell. M shell can accommodate maximum 18 electrons. Then why we write only 8 electrons in the third shell? One more electrons are there. Listen. 2, 8, 8, 1. Total of 2 plus 8, 10. Plus 8, 18. Plus 1, 19. This is a shell electronic configuration of potassium. Why we are writing like this? Here, one electron is present in the N shell, that means fourth shell. In order to understand this concept, in this chapter, we are going to study a new concept. After studying that concept, all of you can understand that why we are writing the configuration like this instead of 2, 8, 9. Are you ready? Okay, all of you listen. We have already told that in shells we can see electrons. K shell having 2 electrons, L having 8, then 18, 32 like that. But in shells where we can see the electrons? In shells where we can see the electrons? In shells there are some region in which the finding electrons is maximum. Finding the probability of electrons is maximum. Such a region is called as subshells. This is a new term. All of you listen. Subshells. What are subshells? Subshells are space or region around the nucleus where electrons are finding maximum, where we can see the electrons. That region is called as subshells. So, what is the difference between shell and subshell? Shells are only the circular paths. In that circular path where we can see the electron, that region is called as subshells. So, in each shells we can see subshells. Okay, listen. We have a table. Listen here. All of you. Shell number, shell, name of shell, shell number, name of shell. What is the shell number 1? Which is the first shell? K. Isn't it? Yes. Then shell number 2. Which is the second shell? L. Good. Then shell number 3, which is the third shell, M. And shell number 4, which is the fourth shell, N. Okay, good. So first shell is the K shell, second is the L, third is the M, and fourth shell is the N shell. In each shells we can have subshells. So we have one more column, subshell present. Subshell present. In the K shell we have a subshell that is known as S. In the L shell we have two subshells. Yes. Okay. So first shell have a subshell that is known as S. Second shell have two subshells. They are S and P. And third shell M have three subshells. Which are they? S, P and D. Okay. The next fourth shell. Fourth shell having four subshells. Which are they? Listen. S, P, D, F. So these are the subshells present in various shells. Then look at the table. I will ask some questions. All of you look at the table. Ready? The first question is, which is the subshell common in all shells? Which is the subshell common in all shells? Look at the table. Which is the subshell common in all shells? Yes, very good. Yes. First shell having S, second shell having S, third shell having S, and fourth shell having S. So S subshell is common in all shells. My second question, is there any relation between shell number and number of subshell present? Once more listen, is there any relation between shell number and number of subshell present? Anyone? Look at the picture. Very good. Both are equal. First shell having only one subshell. Second shell having two subshells. Third shell having three subshells. And fourth shell having four subshells. So shell number and number of subshells present are equal. Okay. Yes. We have already studied that in shells electrons are filling in the increasing order of energy. In the same manner, in subshells, electrons are filling in the increasing order of their energy. Before that, how these subshells can be represented? We have one more column. Listen. Representation of subshell. Representation of subshell. How subshells are represented? Listen. The first shell is K. First shell is the K shell. K shell having only one subshell. So it is represented as, first of all we write the shell number. Shell number 1. This is the first shell and it have only one subshell S. So it is represented as 1S. So this one indicates shell number and this S indicates subshell present. It is read as 1S. Then second shell having two subshells S and P. How can we write that S and P? First of all, write the shell number 2. Having the first subshell S. So it is written as 2S. Second shell having one more shell P. So that is also written as 2P. These two indicate shell number and this S indicate subshell present. These two indicate shell number and the P indicate subshell present. So 1S, 2S, 2p. Then in the same manner, can you write these two columns? Okay, listen. Third shell having three subshells S, P and D. So it can be written as third shell having subshell S, 3S. Then third shell having also two more subshells 3P and 3D. Okay, the last fourth shell having four subshells, it can be written as 4S, then 4P, then 4D and 4F. Okay, so these are subshells. How can we read this? 1S, 2S, 2P, 3S, 3P, 3D, 4S, 4P, 4D, 4F, like that. In these subshells, we can fill electrons. Next, we are going to study how can we fill electrons in these subshells. Okay, listen. Next one is how to write the subshell electronic configuration. Our heading is subshell electronic configuration. How to write the subshell electronic configuration. We know that in shells, electrons are filling in the increasing order of energy. In the same manner, in subshells, electrons are also filled in the increasing order of their energy. So what is the increasing order of energy of various subshells? Look at the board. 1S, increasing order of energy of subshells. This is the increasing order of energy of subshells. First of all, 1S subshell have the lowest energy. Okay. Then next, which is the next subshell, 2S. Then all of you 2P. Good. 1S, 2S, 2P. The next 3S. Next 3P. Next one 3D. Next 4S, like that. This is the increasing order of energy of various subshells. 1S, 2S, 2P, 3S, 3P, 3D, 4S. In order to understand the increasing order of energy of subshells, we have a diagram. All of you listen. We know that first shell having only one subshell, which is that 1S, isn't it? 1S. Second shell having two subshells, which are they? 2S and 2P. 2S and 2P. Third shell having three subshells, which are they? Good. 3S, 3P and 3D. The next fourth shell having four subshells, which are they? 4S, 4P, 4D, 4F. Then this is the increasing order of energy of subshell. Listen. First of all, we fill in electrons in 1S. Electrons are filled in 1S. After 1S, electrons are filled in 2S. After 2S, electrons are filled in 2P. Then 3S. Then 3P. Then 4S. Then 3D. Then 4P. Again, listen. First of all, electrons are filled in 1S. 1s, then 2s, 2s, then 2p, 2p, 1s, 2s, 2p, after that, good, 3s, then 3p, then 4s, then 3d. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Why electrons are first filled in 4s orbital or subshells? Because 4s subshell have low energy compared to 3d subshell. We have already studied that electrons are filled in the increasing order of energy. So 4s subshell have low energy compared to 3d subshell. So first of all, electrons are filled in 4s subshell. After that, electrons are filled in 3d subshells. Okay, listen. So this is the increasing order of energy of subshells. Then while using this, how can we write the subshell electronic configuration? Let us start. We know the first element in the periodic table is hydrogen with atomic number 1. How to write the subshell electronic configuration of hydrogen? All of you listen. Hydrogen, the symbol of hydrogen is H and its atomic number is 1. Hydrogen have only one electron. How to write the subshell electronic configuration of hydrogen? First of all, we have the increasing order of energy of subshells. Which is the first subshell? 1s. 1s. Hydrogen having only 1 electrons. So we can fill these electrons in this subshell S. So these electrons can be written in the upper side like this. And it is read as 1s1. Okay. The second one, which is the second element, helium with atomic number 2. How can we write the subshell electronic configuration? Helium having 2 electrons. So electrons are filled in first subshell 1s. 1s, 2. 1s2. Okay. Then third one, hydrogen, helium, lithium, beryllium, boron, like that. Before that, one more things. We know that cation can accommodate maximum 2 electrons. L can accommodate maximum 8 electrons. M can accommodate 18 electrons. And N can accommodate 32 electrons. Isn't it? Okay. Cation having only one subshell. Yes. So S subshell can accommodate maximum 2 electrons. S can accommodate maximum 2 electrons. L shell having 2 subshells, S and P. L shell having 8 electrons and it have 2 subshell S and P. S can accommodate maximum 2 electrons. So in 8 electrons, 2 electrons are present in S subshell. The remains 6 electrons are present in P subshell. That means P subshell can accommodate maximum 6 electrons. Okay. Then M shell have 3 subshells, S, P and D. S can accommodate maximum 2 electrons, P can accommodate maximum 6 electrons. 6 plus 2, 8. 18 minus 8 remains 10. That means D can accommodate maximum 10 electrons. Then N shell having 4 subshell, S, P, D, F. S can accommodate maximum 2 electron, P can accommodate 6 electron, D 10 electron, F 14 electrons. So all of you should know that S subshell can accommodate maximum 2 electrons, P can accommodate maximum 6 electrons. D can accommodate maximum 10 electrons. F can accommodate maximum 14 electrons. All of you write this in your notebook. S can accommodate maximum 2. P can accommodate maximum 6. D can accommodate 10 and F can accommodate maximum 14 electrons. Okay. After helium, which is the third element, hydrogen, helium, the next one is lithium with atomic number 3. How can we write the subshell electronic configuration of lithium? Yes, first electrons are filled in the first subshell. Which is the first subshell? 1s. 1s. We have 3 electrons. S can accommodate maximum 2 electrons. So 1s2. Then we have one more electron. So that electron goes to second subshell. Which is the second subshell? 2s. 2s. We have only one electron remains. So 2s1. So the subshell electronic configuration of lithium is 1s2, 2s1. Then next one, hydrogen, helium, lithium. The next one is beryllium with atomic number 4. How to write the subshell electronic configuration of beryllium? Listen, first of all, electrons goes to first subshell, 1s. How many electrons? How many electrons? 2. Good. 1s2. Then we have 4 electrons. 2 electrons goes to 1s subshell. Then 2 more electrons are there. Then second subshell is 2s. 2s2. 1s2, 2s2. One more example. The next one is boron with atomic number 5. How to write the subshell electronic configuration? Anyone? Okay. 1s2. We have 5 electrons. 2 electrons goes to 1s subshell. Then 2s3. Not 3 because s can accommodate maximum 2. So 2s2. Then we have 5 electrons. But here 2 plus 2, 4 electrons, 1 electrons remains. Then that 1 electrons goes to 2p subshell. 2p1. So what is the subshell electronic configuration of boron? 1s2, 2s2, 2p1. Okay. So all of you take your notebook, write an assignment. All of you. The question is, write the subshell electronic configuration of following elements. Write the subshell electronic configuration of following elements. Carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Write the subshell electronic configuration of these elements. Carbon with atomic number 6, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay. Write the subshell electronic configuration of these elements in your chemistry notebook and submit to the next class. Okay. After argon, we have a potassium, calcium, scandium, titanium, vanadium up to 30 elements. In the next class, we will study how to write the electronic configuration of remaining elements. Okay. Okay. Thank you.